Imagine floating through space when, in the distance, you see a giant black sphere. It's completely dark, swallowing every ray of light around it. As you drift closer, time begins to slow down. Your heartbeat seems normal to you, but to someone watching from Earth, you appear to move slower and slower until you seem frozen in time. Now imagine crossing a boundary from which there is no return, no signal, no light, no escape. What would happen next? Would you be crushed instantly, stretched into an endless strand of atoms, or could you survive long enough to discover an entirely new universe hidden inside? Black holes are among the most mysterious and fascinating objects in the cosmos. Scientists have learned an incredible amount about them, but what lies beyond their point of no return remains one of the greatest unanswered questions in modern physics. In today's documentary, we'll explore what happens inside a black hole, separating scientific facts from science fiction and uncovering one of the universe's deepest mysteries. Let's begin. Despite their name, black holes aren't actually holes. They're regions of space where gravity has become so incredibly powerful that nothing, not even light, can escape. Most black holes form when giant stars, at least 20 times more massive than our Sun, run out of nuclear fuel. Without the outward pressure created by fusion, gravity wins. The star collapses under its own weight in a matter of seconds, creating one of the densest objects in the universe. The remaining matter becomes compressed into an unimaginably tiny region, while its gravity curves space and time around it. Think of placing a heavy bowling ball on a stretched rubber sheet. The sheet bends. Now imagine something so heavy that it tears the sheet completely. That's a simple way to picture how black holes warp the fabric of space-time. Every black hole has an invisible boundary called the event horizon. This is the point where escape becomes impossible. Outside the event horizon, a spacecraft can still fire its engines and escape. But once anything crosses this invisible line, there is no turning back. Not even light travels fast enough to escape. To an outside observer, something falling toward the event horizon appears to move slower and slower. Eventually, it seems to freeze in place before fading away. But for the person falling into the black hole, everything feels completely normal, at least for a while. Imagine you're an astronaut drifting toward a supermassive black hole. At first, nothing unusual happens. The stars still shine behind you. Your spaceship continues operating normally. But as gravity grows stronger, strange effects begin to appear. Time slows down. The light from distant stars changes color. The universe outside begins to look distorted. Then gravity starts pulling on different parts of your body with different strengths. Your feet are slightly closer to the black hole than your head. That tiny difference becomes enormous. Your feet are pulled much harder than your head. Eventually, you're stretched like a piece of spaghetti. Scientists actually have a name for this process: spaghettification. Your body would become longer and thinner as gravity tears every molecule apart. Near smaller black holes, this would happen before reaching the event horizon. But around supermassive black holes, like the one at the center of our Milky Way, you might cross the event horizon before feeling these extreme forces. Here's where science reaches its limits. No information has ever escaped from inside a black hole. That means nobody truly knows what lies beyond the event horizon. According to Einstein's general theory of relativity, everything falling inward eventually reaches the singularity. A singularity is thought to be a point where matter is compressed into an infinitely tiny space. Gravity becomes infinite, density becomes infinite, and the known laws of physics completely break down. But many scientists believe singularities may not actually exist in nature. Instead, they think our current theories become incomplete under such extreme conditions. To truly understand what happens inside a black hole, scientists likely need a theory that combines general relativity with quantum mechanics, a theory known as quantum gravity. Unfortunately, no one has discovered it yet. For decades, scientists and science fiction writers have imagined an incredible possibility. Could black holes be gateways to somewhere else? Some mathematical solutions to Einstein's equations predict the existence of wormholes. A wormhole would act like a shortcut through space-time, connecting two distant points in the universe. Some theories even suggest connections to entirely different universes. However, there is currently no evidence that wormholes exist. Even if they do, most calculations suggest they would collapse almost instantly. So while it's an exciting idea, it remains purely theoretical. Believe it or not, black holes don't live forever. In 1974, physicist Stephen Hawking proposed something extraordinary. According to quantum physics, tiny particles constantly appear and disappear near the event horizon. Sometimes one particle falls into the black hole while the other escapes. This process slowly steals energy from the black hole. Over unimaginably long periods, the black hole gradually loses mass. Eventually, it completely evaporates. This phenomenon is called Hawking radiation. For massive black holes, this process would take far longer than the current age of the universe. But it suggests that even the darkest objects in existence may one day disappear. For many years, black holes were only theoretical. Then, in 2019, scientists achieved something remarkable. Using the Event Horizon Telescope, astronomers captured humanity's first image of a black hole. The image showed a glowing ring of hot gas surrounding the shadow of a supermassive black hole in the galaxy M87. A few years later, scientists also released the first image of Sagittarius A*, the supermassive black hole at the center of our own Milky Way galaxy. These discoveries confirmed predictions made by Einstein over a century ago and marked one of the greatest achievements in modern astronomy. Now let's wind up this video. Black holes challenge everything we think we know about the universe. They bend space and time, trap light itself, and push the laws of physics to their absolute limits. What truly happens beyond the event horizon remains one of science's greatest unanswered questions. Perhaps one day, future discoveries or a new theory of quantum gravity will finally reveal the secrets hidden inside these cosmic giants. Until then, black holes remain the universe's ultimate mystery. If you enjoyed this journey into one of the strangest places in existence, don't forget to like this video, subscribe to Skywatch World, and turn on notifications so you never miss our next adventure through space, science, and history. Thanks for watching, and we'll see you in the next video.